So there's a really neat thing at the base of your Adam's apple. It's a little butterfly-like little gland going on, hanging out next to it. And it's called the thyroid gland. What it does, it is producing a hormone that is so super important to your metabolism. That is, it is the hormone that establishes your basal metabolic rate. Your basal metabolic rate. So how it's stimulated? You get the thyroid releasing hormone coming from the hypothalamus, which then the thyroid releasing hormone, if you can see it's TSH, thyroid stimulating hormone, you should be able to say, hey, stimulating hormone, that sounds familiar. That should be coming from the anterior pituitary. That thyroid stimulating hormone will come down to the thyroid gland and cause the production and release of thyroxine and triiodothyronine, both of which are hormones that deal with your metabolic rate, but the active form being this one right here, the triiodothyronine hormone. So this gland is really, really neat physiologically, and if you were to physiologically as well as histologically, if you were to do a little quick cross section and look inside of it, you'd see these like little pools of tissue surrounded by these square tile. It almost looks like a swimming pool filled with pink gelatin. What this pink gelatin stuff is actually thyroglobin. This is the stuff that's going to eventually become the thyroid hormones. T3 and T4 for sure. Short. Now, what it looks like in cartoon form is this. Here's the nice little square tiles of the pool. There's the nice liquidy pink gelatin, and then there's the blood right on the outside. If thyroid stimulating hormone comes along and says, hey, it's time to, let's keep on building this stuff, then the blood is going to keep on bringing iodine. It's going to be mixed into the pink pool of goodness. And then when it's fully created, it's fully bound to iodine. It's going to go ahead and these cells are going to cleave off some of these proteins, transfer it into T3, T4, and then release it out into the blood, where it is bound by a globulin, or a type of protein that holds on to T3, T4. Remember that thyroid hormone is fat soluble. It is lipophilic. So something interesting about this one is that it requires iodine. We haven't really seen that iodine need recently. We haven't really seen it in sodium, potassium, or any type of cell membrane potential, but iodine seems to be really important for the formation of these hormones. Again, this thyroid hormone is responsible for your basal metabolic rate. And if you remember, hopefully back from high school, your metabolic rate, when you break down sugar, when you break down things, you release heat. So if you increase how much sugar you break down, you increase the amount of heat that you release. Hence why when you're cold, you start shivering, because you're cleaving off all this extra energy, and you're producing so much more energy to try and heat you up. You can also stimulate protein synthesis. You're going to start building up muscle. You're going to start building up things. You're going to increase the amount of glucose and fat you use. You're going to increase your ability to have a fight or flight response. You're also going to increase how insulin and human growth hormone works. Now, here's some interesting things. We got some homeostatic imbalances, aka something goes wrong inside your body, in particular hyperthyroidism. So hyper means over. So your thyroid is overly working. It's overly thyroidish. We don't overly thyroidish stuff. It's overproducing this T3, T4, which if we pull that apart, it kind of makes sense that you get weight loss. You're increasing your base metabolic rate. You need more fuel for the fire. Where are you going to pull it? From wherever you need. So because you are creating more heat from this process, you're going to become, if someone turns up the thermostat, you go, it's so hot. Oh my word. When it's really just about 65 degrees Fahrenheit. You are increasing the amount of energy that you have, that you're burning, so you're going to be energetic. Oh boy, oh boy, let's go, let's go, let's go, let's go. Whee! Off we go into the wild blue yonder. You could also develop something called a goiter, which this young lady down here in the bottom right corner demonstrates a very pronounced goiter. That's just a giant lump on the throat due to an enlarged thyroid. You can also get exophthalmos, which is being demonstrated in by this young lady here. That's just the eyes are starting to bulge out. The fatty tissues and the tissues behind the eyeball have been stimulated to grow, and they eventually, if not treated, this hyperthyroidism isn't treated, you can get those eyes to start to bulge out. A classic case or an example of hyperthyroidism is Graves' disease. What happens is your body, remember, that has a defense system. It has a whole bunch of cells that wants to fight for you, and some of these cells produce something called antibodies. Well, sometimes these antibodies can be misdirected in their creation and target human tissue, an autoimmune disease. In Graves' disease, it is that, except for the tissues aren't being destroyed. What the antibodies are actually doing is they're binding onto the go button. So you're taking a piece of tape, you're pushing down on the go button, make more, and then you're taping it down, that button down, so it never disengages. So it's continually pushing out thyroid, hormone. Oh no, everything's going crazy. And there's just no stop to it unless you knock out the thyroid itself, pull it out, and then you just supplement with it. You supplement with thyroid hormone. You regulate it manually. Now, the reverse can also happen, called hypothyroidism. You are underproducing thyroid. And the major signs and symptoms, again, is weight gain. Kind of makes sense. If your basal metabolic rate is low, you're not producing very much heat, you're not using up energy. So when you eat something, it eventually ends up, well, not being used, and it's going to get stored away as adipose. You're sensitive to cold. Kind of makes sense. If your metabolism's making a bunch of heat, but your metabolism gets turned way, way down, you're not producing as much heat. So when somebody turns the thermostat down to 70 degrees, then, well, you might be going, it's so cold, I don't understand. Some of y'all, it's fine to be at 70 degrees. I should point that out. I'm just picking on my wife because she's right here. You can also be tired. Makes sense. You don't really have the energy. You could also have a goiter. But that's usually associated with iodine deficiency. How that works is your body really, really wants that basal metabolic rate to go up. So it's releasing TSH, it's releasing TRH. But if you don't have any active thyroid hormone, because you don't have iodine to give it, then that TSH and that TRH is continually being stimulated, saying, hey, more, and then the thyroid says, hey, I'm trying to do my very best. Builds up those pink pools as best as it can, but it doesn't have iodine in there, and just keeps on building more and more until finally, goiter. Now, Hashimoto's is a different story. This is the autoimmune disorder going on here that actually attacks the thyroid and destroys it. Now, because that is the thyroid gland, but I do want to take a moment right now because the parathyroid is hanging out right on the very back of that thyroid. So it just makes sense to talk about it. You got a pair of parathyroid hormones on either side on the very back of it. If you remember go back in time to AMP1, you'll remember that this is the place of your parathyroid hormone formation. Parathyroid hormone is the one that helps break down bones in favor of building up blood calcium. With that, again, it also has something to do with calcitonin. If you remember, that calcitonin is being released to help inhibit osteoclasts and help build up that bone again a little bit. with that, that is the thyroid and parathyroid hormone and the parathyroid hormone, thyroid and parathyroid glands. And I will catch you on the next one.